So when you hear 6G, what do you think of? You know, crazy fast downloads, maybe holographic video calls, right? Well, that's part of it for sure. But the real story, the big story here is so much bigger. The next revolution in wireless isn't really about making our phones better. It's about a massive, fundamental shift in who or what our networks are even for. Yep, you heard that right. By 2030, the entire architecture of our connected world is going to look completely different. And get this, the main user, the primary customer that this whole new network is being designed for, it's not going to be a person. It's going to be a machine.
Okay, so why? Why this huge, radical change? To really get it, we've got to look at the kind of world that's just around the corner. A world that, honestly, our current 5G networks just weren't built to handle.
I mean, just think about it for a second. We're not talking about just a few more smart speakers or watches here. No way. We are talking about swarms of self-driving cars, drones, all coordinating with each other in real time instantly. We're talking about bioimplants on our bodies, skin patches monitoring our health, entire factories that are fully automated, with machines constantly chattering away to each other. This is a future that's built on billions, maybe even trillions, of machines that all need to be connected, all at once, all the time.
And right there, that's the heart of the problem. You see, 5G was an incredible leap, don't get me wrong. But at its core, it was a network designed for people, which we then tried to adapt for machines. And as this research points out, that whole approach just, well, it's not efficient and it's definitely not scalable. It's kind of like trying to run a global shipping empire using a highway system that was only built for family sedans. Sure, you can get a few trucks on there, but it's going to get clogged fast. It just wasn't designed for that kind of load.
So, with 6G, the whole game plan is different. We're basically starting from scratch. It's a total redesign, with a brand new set of rules and new priorities, all built from the ground up with machines in mind.
Let's go back to that highway analogy for a sec. If 5G is the highway built for cars that we kinda squeeze some trucks onto, 6G is a completely new global logistics network. It's designed from day one for autonomous trucks, for shipping containers, for delivery drones. It's what you'd call machine native. It's built for them first. And the cool part is, when you build a network that powerful, it can handle anything we humans want to do and then some.
And this shift in priorities, it's just huge. With 5G, everything was about this simple triangle of goals, right? Speed, low latency, and connecting lots of devices. But 6G blows that up into a hexagon. It adds these new, absolutely critical dimensions like extreme dependability, massive scalability, and, this is a wild one, sensing. We're talking about using the network itself as a kind of giant citywide radar. It's a total game changer.
And the performance jump we're talking about here is, well, it's staggering. Seriously. The goal for reliability is 10,000 times higher than 5G. Think about what that means. That's the difference between your Netflix movie buffering for a second and a remote surgical robot performing a life-saving operation flawlessly with zero glitches. The stakes are just that much higher.
Then there's latency. You know, the delay. That's getting a tenfold boost, dropping from 1 millisecond all the way down to just 0.1 milliseconds. And that speed is absolutely crucial for those real-time control applications we talked about, like a swarm of drones flying information. They need to make instantaneous, perfectly synchronized moves to avoid crashing into each other. You just can't have any lag.
And check this out. How we measure connectivity is changing too. We're now thinking in 3 dimensions. See, 5G aimed for about 1 device per square meter. 6G is targeting up to 10 devices per cubic meter. Why? Because the future is 3D. It's about supporting environments that are literally filled with tech. Drones in the air, sensors on the walls, robots on the floor. It's a whole new way of thinking about space.
Okay, so the big question is, how on earth do you pull all this off? Well, you build what researchers call a network of networks. Now, I know this diagram looks super complex, so don't get bogged down in the details. The big idea here, the main takeaway, is that 6G isn't just one thing. It's an intelligent system that's designed to weave everything together seamlessly. Satellites, cell towers, your Wi-Fi, even those tiny, powerless gadgets we'll talk about, into one giant, cohesive network that just works.
All right, but building this incredible new machine-centric world, it comes with some pretty huge challenges. So let's talk about how we actually make it happen. And the first big hurdle we have to clear is power.
I mean, seriously, how do you power 1 trillion devices? Just think about the sheer logistics of that. It's a massive problem for sustainability, not to mention maintenance. If every single sensor in a field or every smart particle in the paint on a wall needed a tiny battery, well, we'd spend all our time just changing 1 trillion dead batteries. It's impossible.
So the only real solution is to have devices that need basically zero power to operate.
And the key piece of tech that makes this possible is called ambient backscatter communication. Here's a simple way to think about it. Imagine you're trying to send a signal at night. Instead of using a big, power-hungry flashlight, what if you just used a tiny little mirror to reflect the light from a distant lighthouse? You could flash Morse code that way, right? The mirror isn't creating any light. It's just cleverly using the light that's already there. That's exactly what these devices do.
And the result is just incredible. These devices can communicate using something like 1,000 times less power than a normal transmitter. They literally piggyback on the signals that are already floating around us, from TV towers, cell towers, Wi-Fi routers, and they just reflect those signals in a specific pattern to send their own data. This is how we get to that zero-energy Internet of Things. It's brilliant.
Okay, so we've tackled power. The next huge challenge? Coverage. A world run by machines needs a network that is absolutely everywhere, not just in cities and towns where we happen to have cell towers. And that's where non-terrestrial networks, or NTNs, come into play. Basically, 6G is designed to pull satellites, high-altitude drones, and all sorts of other aerial platforms right into the main cellular network. This is the magic that lets you connect smart sensors on a farm for precision agriculture, or track a shipping container in the middle of the Pacific Ocean, or monitor a pipeline out in the desert. It finally makes the network truly global.
But listen, for a lot of these future applications, just having a connection isn't good enough. The connection has to be absolutely perfect, all the time. Because the stakes, they're going to be incredibly high.
This is what leads us to a whole new class of service called critical machine-type communication. We're talking about situations where the network is controlling a surgical robot, or managing the entire power grid, or coordinating a fleet of self-driving cars. In those moments, failure is it's not an option. The connection has to be as steady and dependable as a surgeon's scalpel. So the goal here is something called taming the tail of the performance curve. What does that mean? It means it's not good enough for the network to be fast on average. Averages don't cut it. For these mission-critical jobs, 6G has to provide guaranteed performance, with basically zero data loss and a totally predictable, unwavering reliability, every single time.
All right, and that brings us to the final piece of the puzzle. And it might just be the biggest challenge of all. When you have a world run by 1 trillion interconnected machines, how in the world do you keep it secure?
The potential attack surface is just mind-boggling. You can't exactly have a password for every one of 1 billion tiny sensors, right? It's just not possible. So the whole way we think about security has to change. It needs to be built in from the ground up, using AI to spot threats automatically. And it'll likely use things like distributed ledger technologies. Think of it like a super secure shared digital notebook that allows all these different machines to trust each other without needing some central server to vouch for everyone. It's less about building one big wall, and more about creating a web of trust across this massive global ecosystem.
So that's the big picture of 6G. It's a network that's ridiculously reliable, almost infinitely scalable, and built from its very core for a world of autonomous machines. It's going to unlock a future of unbelievable efficiency and automation, which, leaves us with one last really big question. This network will quite literally put machines in charge of running large parts of our physical world. So, are we ready to let them drive?